Dear students, in today's session, let us discuss KCET 2019 physics question paper. Watch full video that may help you to score more in the upcoming examination. And if you like this video, please subscribe and hit the bell icon to get notification of my videos. Okay, let's get started. Let's have a look on the very first question. That is, in a cyclotron, a charged particle undergoes acceleration all the time, speeds up between the D's because of the magnetic field, speeds up in D, slows down within a D and speeds up between D's. As we all know that in a cyclotron, a charged particle experiences electric force between the D's and magnetic force inside the D's while circulating. So it experiences force all the time. Either it may be electric force or magnetic force. So if it is experiencing the force all the time, it must experience acceleration all the time. So option A would be the right answer. In another way, if you want to say, as we know that the acceleration is nothing but, that means a body is said to be accelerated if its velocity changes or if its direction changes. So here, while circulating, this charged particle is changing its direction at every instant of time. If the direction is changing at every instant of time, then a charged particle is said to be accelerated at all the time. So option A is the right answer. In the B option, it speeds up between the D's. Yes, a charged particle speeds up between the D's, but not because of the magnetic field, it is because of the electric field. So option B is not correct answer. Next, between speeds up in D or slows down within a D. So within a D, there won't be any increase or decrease in the speed of the charged particle. It only speeds up between the D's because of the electric field. So that is the thing. Okay. So option A is the correct answer for this question. Okay, let's have a look on the next question. That is, the number of turns in a coil of galvanometer is tripled. Then voltage sensitivity increases 3 times and current sensitivity remains constant. Voltage sensitivity remains constant and current sensitivity increases by 3 times. Both voltage and current sensitivity remains constant. Both voltage and current sensitivity decreases by 33%. Here we need to find out how voltage sensitivity as well as current sensitivity change when the number of turns of the coil of galvanometer changes or tripled. So as we know that the current sensitivity, that is current sensitivity is given by, that is deflection produced in the galvanometer per unit current, and this is given by NBA by K. Okay, now as the number of turns increases, then the current sensitivity increases. By this formula we can say that if the number of turns increases, then current sensitivity increases. So here the number of turns of the galvanometer is tripled. So when the number of turns increases by 3 times, then the current sensitivity also increases by 3 times. So here we can see in the option B, we can see that the current sensitivity increases 3 times. Now let's check the voltage sensitivity. That is, voltage sensitivity is nothing but the deflection produced in the galvanometer per unit voltage. That is given by, already we know that V equals to IR, that is psi equals to IR. Just now we have written psi by I here. Psi divided by I is nothing but what? NBA divided by K, and here we have R. So therefore here you can see that as the number of turns increases here, then we know that when the number of turns increases, there will be change in the resistance, because when the number of turns increases, length of the conductor increases. Here the number of turns increases by 3 times, so therefore length will become 3L, and resistance is directly proportional to L, as we know that. So the resistance becomes 3R. So here if it is increased by 3 times, that is 3N VA divided by R, then in place of R we must write 3R, because resistance increases by 3 times as the number of turns increases by 3 times. So 3 get cancelled, we will get again NBA divided by K. So therefore KR. So therefore there won't be any change in the voltage sensitivity of the galvanometer. So if I increase the number of turns. So by this you can understand that the B would be the proper answer. Okay. Let me go for the next question, that is a circular current loop of magnetic moment M is in an arbitrary orientation in an external uniform magnetic field B. The work done to rotate the loop by 30 degree about an axis perpendicular to its plane is. So let me consider a circular loop which is carrying the current in the clockwise direction. So if the current is moving in the clockwise direction, then the direction of the magnetic moment, which is given by the right hand thumb rule, that is M. The direction of the magnetic moment will be acting in the direction by using right hand thumb rule. So the current is moving in the clockwise direction. So let me place this circular current loop in the external magnetic field, external uniform magnetic field. Let me consider the uniform magnetic field is acting in this direction. If I place the loop in the external magnetic field, now you look at the angle between the magnetic field and the magnetic moment, that is angle 0. So as we know that the work done to rotate the loop in the magnetic field is mb cos theta 2 minus cos theta 1. As we know that the theta 1 is the angle between the magnetic field and the magnetic moment before rotating the loop, and theta 2 is the angle between the magnetic field and the magnetic moment after rotating the loop. So now suppose if I rotate the loop by 30 degree about an axis perpendicular to its plane. So if I rotate the loop like this, there is no change in the direction of the magnetic moment and the magnetic field. That means the angle between the magnetic field and the magnetic moment will not change if I rotate the coil by 30 degree about an axis perpendicular to the plane. So whenever we rotate this loop perpendicular to the plane, there is no change in the angle between the magnetic moment and the magnetic field. So therefore theta 2 is equals to theta 1. So mb, whenever theta 2 equals to theta 1, cos theta 2 equals to cos theta 2. So this will become cos theta 2 is equals to cos theta 1. So it will become 0. So work done is equals to 0. So option D would be the correct answer. Let's have a look on the next question, that is, in a permanent magnet at room temperature, magnetic moment of each molecule is 0. The individual molecules have a non-zero magnetic moment which are all perfectly aligned. Domains are partially aligned. Domains are all perfectly aligned. As we all know that a permanent magnet at room temperature retains a ferromagnetic property that always possesses magnetic moment. So the magnetic moment of each molecule is 0 they have given, so this is not correct because it always possesses magnetic moment that is not equals to 0. Next, due to the thermal agitation which is at room temperature, so therefore due to the thermal agitation, domains are always partially aligned, not perfectly aligned. So option C would be the correct answer. Let's have a look on the next question, that is, coercivity of a magnet where the ferromagnet gets completely demagnetized is 3 into 10 to the power of 3 ampere per meter. The minimum current required to be passed in a solenoid having 1000 turns per meter so that the magnet gets completely demagnetized when placed in the solenoid is. Here the coercivity, which refers to the intensity of the magnetic field where the magnet gets demagnetized, that is the intensity of the magnetizing field. So this is what H. As we know that intensity of the magnetizing field is 3 into 10 to the power of 3 ampere per meter. And as you know that the magnetic field due to the solenoid is given by B equals to mu naught Ni. And this B, that is magnetic field, can be expressed in terms of magnetizing field, that is magnetic permeability times the magnetizing field, that is mu naught H equals to mu naught Ni. So here mu naught get cancelled, so we get H is equals to Ni, thereby we can get I equals to H divided by N. Here H, that is intensity of the magnetizing field, here we have 3 into 10 to the power of 3 divided by number of turns, that is 1000 turns per meter. So it will become 10 to the power of 3 divided by 1000 is nothing but these will get cancelled and we will get 3 ampere. So I is equals to 3 ampere. So option C would be the right answer. Moving to the next question, that is, which one of the following nuclei has a shorter mean life? Here mean life is given by, that is tau equals to 1 upon lambda. If lambda is more, that is decay constant is more, then the nuclei will be having a shorter mean life. So we know that the activity is equals to, that is dN by dt is equals to n lambda. If lambda is high, then activity will be more. See here, the higher slope in this graph, the higher slope represents more activity. If there is more activity, then there will be less life, that is less mean life. So among these graphs, that is slope of A is greater than the slope of B, and this which is greater than the slope of C. So if the slope is more, then activity of the A will be more than the activity of B, which is greater than the C. So if the activity is more, then lambda will be more. If the lambda is more, then that nuclei will be having less mean life, that is shorter mean life. So here activity of the A is more from this slope. So therefore the A nuclei having shorter mean life, and C nuclei which is having slope less. So activity is less. If the activity is less, then it will be having greater mean life. So C having greater mean life, whereas the A having shorter mean life. So A is the correct option. Let's move to the 7th question, that is, the conductivity of a semiconductor increases with an increase in temperature because option A, number density of charge carriers increases, B, relaxation time increases, C, both number density of charge carriers and relaxation time increases. Last, the number density of current carriers increases, relaxation time decreases, but the effect of decrease in relaxation time is much less than the increase in number density. As we have an relation between conductivity, number density and relaxation time, that is conductivity is equals to number density E square tau divided by m. This is the relationship between conductivity, relaxation time and number density. As we know that if there is increase in the temperature, the electrons present in the valence band will jump to the conduction band. Thereby number density increases. As the number density increases, the conductivity increases, as they are having the linear relationship. So as the number density increases, conductivity increases. Now let me write this expression in terms of relaxation time, that is tau is equals to rho m divided by n e square. Now as we know that if the temperature increases, the number density increases. So if the number density increases, what about the relaxation time? Relaxation time decreases. But as we know that the conductivity of semiconductor increases with increase in temperature, that is because of increase in the number density, but there is a decrease in the relaxation time. This decrease in the relaxation time will not affect much to the conductivity. So therefore here you can see the options, the number density of charge carriers increases, relaxation time decreases, and the effect of decrease in the relaxation time is much less. So option D would be the correct answer for this. Okay, let's have a look on the next question, that is, for a transistor amplifier, the voltage gain remains constant for all frequencies, is high at high and low frequencies and constant in the middle frequency range, is low at high and low frequencies and constant at mid frequencies, constant at high frequencies and low at low frequencies. When we look at the frequency response curve of a transistor amplifier, we will get like this. By this graph, we can say that the voltage gain is constant at the mid-range frequency, that is the middle frequency range. At the middle frequency range, the voltage gain is constant, and the voltage gain is less at low frequency and voltage gain is less at more frequency also. That means whenever the frequency is less and more, the voltage gain is less only, but only it is constant, that is voltage gain is constant at the middle frequency range. So here we can see that is low at high and low frequency, it is The voltage gain is low at high as well as low frequencies and constant at mid frequencies. So option C would be the correct answer. Okay, let's move to the ninth question. That is, here in the following circuit, what are P and Q? See, in the circuit we can see two NOR gates. So first let me draw the truth table for the NOR gate. So if the truth table having the inputs A and B, that is 0 0 0 0 1 1 0 1 1, then output will be like this, that is A plus B bar. The output of the NOR gate will be 0 0 1 0 1 0 1 0 0 1 1 0. This is the truth table of NOR gate, as we all know that. Now by this truth table we can understand one thing, that see, the NOR gate gives an output 0 if any one of the input is 1. If any one of the input is 1, then output will be equals to 0. So here you can see that here the input is 1. So therefore output will be equals to how much? 0. Any one of the input, if there is any input is 1, then output will be equals to 0. So therefore P equals to 0. Now if P equals to 0, then the input of the one input of the lower NOR gate is equals to 0. So 0 0, which implies that 1. So therefore P equals to 0, Q equals to 1. So here P equals to 0, Q equals to 1. Option C would be the correct answer. Okay, let's move to the 10th question. That is, an antenna uses electromagnetic waves of frequency 5 MHz. For proper working, the size of the antenna should be. As we all know that for effective transmission and reception of a signal, the height of the antenna, that is the height of the transmission or receiving antenna, should be comparable to the 1/4, that is quarter of the wavelength of frequency used. That is the minimum length, of the antenna should be equals to quarter of the wavelength of the frequency used. So that is nothing but here 1/4 lambda can be written as C by F. As you know that C equals to 3 into 10 to the power of 8 and the frequency is 5 megahertz, that is 5 into 10 to the power of 6. Mega means 10 to the power of 6. So therefore here 3/4 is nothing but 0.75 divided by 5 into 10 to the power of 8 divided by 10 to the power of 6 is 10 to the power of 2. So therefore 75 divided by 5. So 75 divided by 5 gives us 15 meter. So therefore the minimum length of the antenna should be equals to 15 meter. So option A would be the correct answer. So here in these options, that is D, 3 kilometer, 15 kilometer and 300 meter. These options are absurd. Directly we can mark the 15 meter is the minimum length of the antenna for proper working. So therefore A is the correct answer. Let me go for the 11th question. That is, if P, Q and R are physical quantities having different dimensions, which of the following combinations can never be a meaningful quantity? As we all know that according to the principle of homogeneity of dimensions, addition and subtraction, direct addition, direct subtraction between the two quantities which are having different dimensions is not allowed, or it is not possible. That will give or meaningless physical quantity. Okay, whereas the multiplication and division of the two physical quantities which are having different dimensions is possible. Not only that, the multiplication come subtraction, multiplication come addition also allowed between the two quantities having different dimensions. So according to this principle, so here P minus Q, it is direct subtraction, so which is not possible. So this option, that is A option, can never be a meaningful quantity. Not only the, so therefore option A would be the correct answer. Whereas P Q minus R, PQ, this is multiplication come subtraction is allowed according to the principle of homogeneity. Next, PQ divided by R, that is multiplication come division is also allowed. Multiplication come division, multiplication come addition, multiplication come subtraction is allowed during from the principle of homogeneity. Not only that, PR minus Q square divided by R is also allowed according to the principle of homogeneity of dimensions. So therefore option A can never be a meaningful quantity from the principle of homogeneity of dimensions. Okay, so therefore option A is the right answer for this question. Okay, let's move to the next question. That is, the given graph shows the variation of velocity with the position for a particle moving along a straight line. Which of the following graph shows the variation of acceleration A with the position x? So in the given graph, this graph, when we consider this graph, we can write the equation for this graph, that is y equals to mx plus cr. See here we know that the slope for the straight line which is inclined to the x-axis is positive, but this straight line is inclined to the y-axis, so therefore the slope is negative x plus intercept. Here the constant thing is v0, that is initial velocity, so v0. So this is what v is equals to, along y-axis there is change in the velocity, v equals to minus mx plus v0. Why we have taken here minus? Because the straight line is inclined to the y-axis, so therefore minus m. Now if I differentiate this equation, that is with respect to time, we will get dv by dt is equals to, so minus, that is d divided by dt minus mx plus v0. Whenever I differentiate this, we will get dv by dt is acceleration, and differentiation of minus mx gives us minus m, dx by dt is velocity, plus the differentiation of the constant is 0. So therefore we will get acceleration is equals to minus m v. Already we know that v equals to, that is v from this equation, that is we can write v is equals to minus m of minus mx plus v0. So which gives us, that is a is equals to minus and minus plus m square x plus, sorry, this minus and minus, it will become, sorry, minus and plus becomes minus m v0. Now by looking at this equation, we can select the graph which is having positive slope and negative intercept. The positive slope, so this equation gives us the positive slope, that is positive slope, and negative intercept, that is negative intercept. So among these four graph, which is having positive slope and which is having negative intercept, that we need to find out. So keep in mind that the straight line which is inclined to the x-axis will be having positive slope, and the straight line which is inclined to the y-axis will be having negative slope. Here we can see that this option A, which is having the negative slope, this is negative slope, and this is having 0 slope, whereas this one having positive slope, because which is inclined to the x-axis, and D option which is having negative slope. So therefore option C would be the correct answer. And moreover, this C here, this is having negative intercept also, positive slope and negative intercept. So both are here in the option C. So therefore option C would be the correct answer. Okay. Let me move to the next question, that is 13th. The trajectory of a projectile projected from the origin is given by the equation y equals to x minus 2x squared divided by 5. The initial velocity of the projectile is, as we know that the trajectory of a projectile is given by the equation, that is y equals to x tan theta minus gx square divided by 2u square cos square theta. This is an equation for the trajectory of a projectile, that is parabola equation. Now the given equation is y equals to x minus 2x square divided by 5. And comparing these coefficients, we will get the tan theta is equals to, and comparing these two, we get here in place of tan theta we have 1 here, so therefore tan theta is equals to 1. That means theta equals to 45 degree. So here on comparing these, that is in place of 2 divided by 5 we have, that is 2 divided by 5 is equals to, so g divided by 2u square cos square theta. So here we know that the theta equals to 45 degree, cos 45 is 1 by root 2. So here cos square theta, so 1 by root 2 into 1 by root 2, that is 1 by 2 only. So that is g. Well, let me take g value as 10 meter per second square, and 2 and u square, and here cos square theta is 1 by 2. So now 1 by 2 and 2 get cancelled. We will get here 2 by 5 equals to 10 divided by u square. So therefore here u square is equals to, this u square is equals to 50 divided by 2. So this is equals to 25. that is u equals to root 25 is 5 meter per second. So option B would be the correct answer. So let me move to the next question, that is an object with mass 5 kg is acted upon by a force, that is F vector is equals to minus 3I cap plus 4J cap Newton. If its initial velocity at t equals to 0 is V vector equals to 6I cap minus 2J cap meter per second, the time at which it will just have a velocity along y-axis is, see here we have mass as well as force, so therefore we can find out acceleration, that is acceleration is equals to from the Newton's second law of motion force by this is equals to F is minus 3I cap plus 4J cap divided by m is 5 kg. So therefore here we can write directly, that is minus 3I cap minus 3 by 5I cap plus 4 by 5 J cap acceleration is equals to this much. Now, so as its initial velocity, that is initial velocity is equals to 6I cap minus 2J cap, that is at t equals to 0. We have the time at which it will have just a velocity along y-axis. So as we know that the velocity is equals to u plus at, and here velocity along the x-axis, let me write velocity along the x-axis, initial velocity along x-axis, acceleration along x-axis. As we know that the velocity along y-axis they are asking, so therefore velocity along x-axis will become 0, and here they have given the velocity, initial velocity along x-axis, that is the coefficient of I cap, that is 6. We can write 6 plus ax, here along x-axis, acceleration along x-axis, coefficient of I cap is minus 3 by, that we write here minus 3 by 5, and here t. So therefore, so 3 by 5t is equals to 6. So therefore t is equals to 6 5 ja, so 6 5 ja 30 divided by 3. So therefore t equals to 30 seconds, sorry, t equals to 10 seconds. So option B would be the correct answer. Okay, let's move to the next question, that is during inelastic collision between two objects, which of the following quantity always remains conserved? As we all know that during the collision no external forces are acting, external forces are not acting on the colliding bodies during their collision. So therefore the total linear momentum is always conserved in all the type of collisions, but the kinetic energy is not conserved in all the type of collisions. But we know that the total kinetic energy or kinetic energy is conserved only in perfectly elastic collision, but some kinetic energy is lost during inelastic collision. So therefore the total kinetic energy is not conserved in inelastic collision. So therefore option C would be the correct answer. Total linear momentum is always conserved in all the type of collisions. Okay, so let me move to the next one, that is 16th one. In Rutherford experiment, for a head-on collision of alpha particles with a gold nucleus, the impact parameter is 0 of the order of 10 to the power minus 14, of the order of 10 to the power minus 10 meter, of the order of 10 to the power minus 6 meter. As we all know that the impact parameter is the perpendicular distance between the initial velocity vector of the alpha particle and the center line of the nucleus. For head-on collision, the alpha particle will be moving along the direction of the center line of the nucleus, and it retraces its path after reaching the distance of the closest approach. So therefore, if it is moving along the direction of the center line and then if it retraces its path, then the perpendicular distance between the initial velocity vector of the alpha particle and the center line of the nucleus will become 0 for head-on collision. So therefore, the impact parameter is 0 for head-on collision. So option A would be the correct answer. Let me move to the next question, that is frequency of revolution of an electron revolving in nth orbit of hydrogen atom is proportional to. As we know that the time period of the revolution of the electron is equals to, that is one revolution. For one revolution we can write distance is 2 pi r divided by v, t equals to distance divided by velocity. As you know that the radius of the electron in the nth orbit is directly proportional to is r is directly proportional to n square, and this velocity, the velocity is directly inversely proportional to n, that is 1 divided by n. So therefore the t is directly proportional to n cube. If t is directly proportional to n cube, as we know that the frequency is equals to 1 upon t. So therefore this is directly proportional, that is frequency is directly proportional to, that is 1 divided by n cube. So therefore option D would be the correct answer. Let's have a look on the next problem, that is a hydrogen atom in ground state absorbs 10.2 electron volt of energy. The orbital angular momentum of the electron is increased by, that means change in the angular momentum we need to find out. Here the hydrogen atom is in the ground state, absorbs this much amount of energy. So as we know that the energy of the electron in the nth orbit, that is En equals to minus 13.6 divided by n square electron volt. So as we have seen that from the energy level diagram, if n equals to 1, then the energy will be minus 13.6 electron volt, and if n equals to 2, then it is 3.4 electron volt, and if n equals to 3, then it is minus 1.5. If n equals to 4, so it is equals to minus 0.8 something. So we will get like this. Now the difference between these two, let me consider the difference between these two, that means minus 3.4 plus 13.6 electron volt gives us the 10.2 electron volt if we calculate. So therefore now the electron is in the second orbit. If the hydrogen atom in the ground state absorbs, if it absorbs 10.2 electron volt, then the electron will be in the second orbit, that is n2 equals to 2 here. So as we know that the change in the angular momentum is equals to the angular momentum in the second orbit minus angular momentum in the first orbit. So therefore here L2 can be written as n2, that is h divided by 2 pi minus n1h divided by 2 pi. Here we know that n2 equals to 2h divided by 2 pi minus, here n1 is 1, so that is 1h divided by 2 pi. So if I calculate, this will become h divided by 2 pi. I am substituting the values, that is h is equals to 6.623 into 10 to the power minus 34 divided by 2 into the pi value is 3.142. So 3.142. So therefore that is delta L is equals to, here 6.6263 into 10 to the power minus 34 divided by 2 into 3.142 is 6.284. So therefore 6.6 divided by 6. So here clearly we can see that it is 1 point something. So here in the options we can see that option A, that is 1.05 times 10 to the power minus 34 joule second. So option A would be the correct answer. Okay, let's have a look on the 19th question, that is the end product of decay of thorium is lead. The number of alpha and beta particles emitted are. Let me consider the alpha particles, number of alpha particles are x and number of beta particles are y. So therefore here the thorium, that is thorium 23290, which is becoming lead, that is Pb 20882 plus helium particles, let me take plus beta particles, that is 0. So now let me take the number of alpha particles are x and number of beta particles are y. Now on comparing the atomic number, we will get 90 is equals to 82 plus 2x minus y. Okay, so now 2x minus y, 2x minus y is equals to, that is 90 minus 82, that is 8. Let me consider this is equation number 1. Now on comparing the mass number, that is 232 is equals to 208 plus that is 4x. So here the 4x is equals to 232 minus 208, that is 24. So x is equals to 24 divided by 4 is 6. So x equals to 6. On substituting this value in the equation number 1, we will get y, that is y is equals to, that is 2x, that is 2 into 6 minus y is equals to 8. So therefore y is equals to, that is 12 minus 8. So this gives us y equals to 4. So number of alpha particles are 6 and number of beta particles are 4. So therefore x is equals to 6 and y equals to 4. Here option B would be the correct answer. Okay, let me go for the next question. That is, two protons are kept at a separation of 10 nanometer. Let Fn and Fe be the nuclear force and the electromagnetic force between them. So here the nuclear forces are short range forces, and the nuclear force will act only when the separation between the two protons is less than or equal to 10 to the power minus 15 meter. But here the separation between the two protons is given, that is 10 nanometer. This 10 nanometer is nothing but 10 to the power minus 8 meter. This is very greater than 10 to the power minus 15 meter. So therefore the nuclear force will not exist, or nuclear force is negligible in this case. So therefore only electromagnetic force is very greater than the nuclear force in this case. So therefore option B would be the correct answer. Okay, so this is the option. Okay, let me continue my discussion in the next video. If you like this video, please subscribe and get the notification of my videos. Okay, thank you one and all. Have a nice day.